In this video, I'll show you how you can use graphs to solve inequalities and also show you one common mistake that students make when it comes to inequalities. So you are given an equation which looks like this. You have minus x squared plus x plus 2 is less than or equals to 0. So each and every time you are using a graph to solve this, you're going to consider two parts of your equation, your left hand side and your right hand side. This one will be the one that you're going to use to draw your graphs. You're going to work out your factors. Then this one is the one that is going to be used as your restriction. So we'll start on the left hand side. So if we're having minus x squared plus x plus 2 and we want to factor it out, a quick way would be to take the negative outside. We have negative into our x squared, then it will be minus x minus 2. So it's going to be something that looks like that. So remember, if I take the negative and multiply it throughout, I must be able to get back to that very same equation that I had. You see? So now we can continue with this part and say, okay, we have to find out the factors for this one. So let's just write it here that we have minus into x squared minus x minus 2. So we're trying to look out for the factors for that one. So let's just do our two brackets. So which approach are we going to use? When you're trying to factorize this one, you always try and look at this number and the one in the middle. So you're going to ask yourself, which two numbers can you multiply that will give you minus 2, and when you add them they give you minus 1. So those numbers are going to be what? It's going to be minus 2 and also positive 1. And you have to at least test again. So when you multiply them, are they giving you minus 2? Minus 2 multiplied by 1, it gives you minus 2. Then when you add them, do they give you minus 1? And yeah, minus 2 plus 1, it gives you minus 1. So it means now we have the correct factors. So you're going to continue and say you have what? You have your, this minus, we'll just write it, we still have to write that one. You have x minus 2 into your x plus 1, then yeah, this will be equals to 0. Then you just focus on solving the brackets. Your x minus 2 is equals to 0, or your x plus 1 is equals to 0. Your x could be 2, or your x would be equals to minus 1. So the minus 1, do not worry about it, you just leave it like that. So I'm going to continue this side and try to draw the graph. So we've worked out the x values. Let's say here we have the minus 1, we have the minus 1, then this side we have the 2. Then from this we know we can read that our y value is going to be 2. How do we read this one? We said if you are trying to find your y values in this concept, or when you're doing your graph, you basically let all your x's be equals to 0. So if you let them be equals to 0, it means now this value that you're going to get here would be 2. Remember this, it's your parabola. So if you did this in your high school and college, you would be able to spot it out that this would definitely be your 2. Then your x values, you'd be able to work them out by factorizing. So now comes the second part. You check the shape of your parabola by looking at the slope. The slope is negative, it means that's going to be a graph that looks like this. If it was positive here, it was going to look like this. So already, even if they tell you without having to calculate the values, draw this graph, you would have drawn using this 2 and this 1. Even if they are known, you were still going to draw a shape that looks like that. But now you were able to calculate them, so it means you can just go and finalize and write something that looks like this. So that's basically how you get to your graph part. The second part, remember I said this one is the one that helps us to write the graph, and this one is the one that tells us about the restriction. You see, they say you have to tell us in a region where this graph it's less than or equals to 0. Where is that region? The region that I can see, it's is this one here, and also this region here. And if you check, does it satisfy this? Yes, it does. In this region, it is indeed less than or equals to 0. So what are you going to write in your formula? No, your final answer. So let me just in your final answer, you will say you have your x is less than or equals to -1. So this basically means that you have your values that are starting from -1 and including 1 up to your negative infinity. So each and every time you see plus a less than or equals to sign and it's like this, it means now you're going to use this sort of a bracket that shows the restriction. So that's that part. So now you have to talk about the other part, or x is greater than or equals to 2. So this one, it will be everything from 2 including 2 up to your positive infinity. So that's how you would write it in your interval notation. Remember, they would ask you to do it in a set notation or interval notation. Your set notation would be like this. You would write something like your x is such that your x, remember you still have to write those so those Cayley form of a bracket, that it's going to be something like that. But if it was an interval, you're going to write it in the other way. So now comes the part where student makes a mistake, because I want you to see something. So now let's just say you still have inequalities. They tell you that you have, I'm just trying to think of a perfect example. Okay, you have your x squared minus x minus 2 is less than or equals to 4. So the key things now, let's just say here they said solve the inequality. So the key thing here to remember is to check if they're talking about the graph, or they're just saying you should just focus on solving the inequality. Because in this example, this is the part where you have to take this value to the other side. So you're going to be having x squared minus x minus 2, it will be less than or equals to 0. then you continue solving it going down. But in this instance, you consider the two parts. You don't take whatever that's on the right and move it to the other side. You see? So now let's just say we are done with this example, and now they say this is 1. Number 2, they say you have minus x squared plus x plus 2 is less than or equals to 3. This part is still going to be the same like this, but now the restriction now changes. Let me just rub that one. The restriction now changes, or you also still need to consider that other side. Here you have your minus 1. So now if you have your 3 here, it means you're gonna come to this line and indicate that 3 here. So you will say you have your y equals to 3. So now they're asking you, okay, in which region of the graph is your graph less than or equals to 3? You can see that you are basically going to cover everything. You see, because you are having everything covered along this side. So you're basically going to be saying from minus infinity to positive infinity. So it's more or less as if like now it's two graphs, whereas you are comparing them. They now want in which region is this one less than this second graph that you just written. You see, so you have to be careful when you are doing this type of example. So you see, but in this one, since we're not doing graph, we can be able to take the 4 to the other side. Then let's just quickly solve this one so that you know how you would go about solving this. So this one is going to be minus 6. You see, so if you have this, I'm just going to quickly write the factors of 6 is 3 and 2. Then the one that if you multiply them together, they give you minus 6. Yeah, it's definitely minus 3 and plus 2. So I'm just going to say you have your x minus 3, then you have your x plus 2 less than or equals to 0. Therefore, you know now your x would be equals to 3, or your x would be equals to minus 2. So how would you write this one? You would write it as minus 2 is less than or equals to your x is less than or equals to 3. Or this basically just tells you, since we have this sign, it tells you you can write it in an interval notation, that this would be between minus 2 to 3. Remember, they sometimes ask you to write it in a set or interval. A set will always be those curly lines. So how I would remember it is, okay, when you are having your set, it can be normally a set of hair or Brazilian hair, something like that. That's one example I would use to remember. Then I would know the interval would definitely be this one. Sometimes it can be a combination of a bracket. It's not always this ones. These ones you only know if you're having something that is included in itself within that criteria you're working on. So in this instance, where you have less than sign, less than or equals to sign, or greater than or equals to sign, that's when you would use the graph like that. But for instance, let's just say it was something like this, you wouldn't use this one. It was gonna be something like this. So now you see the difference between the two and the restrictions. So if you have this, then one another way that they would use, okay, so I'll have to erase this part so that I can finish explaining the one here. So one another way that they would use is that, okay, you have to write this solution on a number line. So how do you go about doing that on a number line? You have your 0 here, you have your -2, then you have your 3 here, you see. Then if your formula was given at whatever, your f of x or your g of x, you do the correct numbering and everything so that you get all your marks. So now you're going to write a dot this side and also a dot this side, and you connect them together. So one thing to note, you only shade this dot if you're having a restriction that is like this. If you're having a restriction that that's like this or like that, what's this, less than or equals to sign or greater than or equals to sign, that's only when you are shading. It basically means you are also you are including everything starting from -2 up to 3 and also including 3. But if I say, I will just explain it again, that you're including everything, including -2 up to 3, and also the 3 is included itself. So you're going to be having something that looks like this. But in an instance where we had something that looks like this, so this one wasn't going to be shaded, it was going to be like this, you see, and here it was gonna be like that. But now it's a completely different case. We have it like this, so even here we have to shade. So the more you do these examples, the more you'll be able to see, okay, if we're having this particular restriction, we do it like this, then if not, we're going to do it like this. So you see now this small difference between these two. When you're using the graphical method, you solve this as 2 pi. When you're just doing your normal linear equations, you take this part or whatever that you have on your right hand side, then you transfer it to your left hand side, then you start doing your calculations and your vectorizing. So yeah, that's one thing that you have to look out. So see you on the next video.